So while we're on the topic of solutions, let's also talk about solubility. And solubility, it sounds like solutions. It deals with the maximum amount that I can dissolve one substance into another. So this is kind of like our tipping point. So literally what we would do to test this, we would just say, if we're testing salt's solubility, we would start adding salt, and then eventually we'd see some salt start to pile up at the bottom of that beaker. And so eventually we hit what's called a saturation point. So a point in which we can't get any more of that solute, in this example, salt, to dissolve into our solvent, which in this example, again, is water. Again, thanks to scientists, this is already done for us. Somebody sat around and they meticulously got this information for us. And if we use this example of copper sulfate as a hydrate here, if we were to actually plot some of these points, this is what we call a solubility curve. And you'll be able to be asked to interpret one of these. We'll practice that later. But basically, we're plotting these points. So at 0 degrees Celsius, we can put 23 grams of that copper sulfate heptahydrate into 100 grams of water. So once we plot all those points and connect the dots, what we end up with is this nice what we call solubility curve. Now what you'll notice is that these points are actually increasing along with the temperature, right? So a lot of substances, not all, but a lot of substances, when we increase that temperature, we can put more of the solute into that solvent. So here we have the solubility curve actually labeled. This is, again, probably something that you might want to add to your notes. So this line we call the maximum solubility, right? So above this line, take 0 degrees, for instance. We said that we could put, I think, 23 grams of that copper sulfate in. If I add 24, well, that extra gram that I put in there isn't going to dissolve. So imagine what that kind of looks like. I have just 23 grams dissolves into the solution, and then that extra gram just kind of sits there. Kind of like it's too full to really be absorbed, or excuse me, I should say dissolved into the substance. So you'll notice, though, if I add some heat to it, right, I can actually get that, say, 24 grams of my copper sulfate to actually dissolve. So two terms that we want you to be aware of here: when something is full, when it's when you can't add any more to it, any more solute to it, we call that saturated. And then if a solvent is unsaturated, that means that we could still add more of that solute to it. So here's a typical solubility chart that we would ask you to be able to interpret. So this has a bunch of different compounds on it, and they're signified with different colored lines here. You'll notice that we do have one here, one of those exceptions, lithium sulfate here, actually can dissolve less as the temperature goes up. And the reason for that, we'll get more into the next unit when we talk a little bit about Le Chatelier's principle. But just kind of important to note that this is one of the few substances here that, actually decreases in solubility with an increase in temperature. We would expect the temperature to go up because we're adding more energy, and therefore there's more energy to be able to break up that solute. So let's try a sort of sample problem here. If you have 60 grams of ammonium chloride, and let's just kind of identify ammonium chloride here. It looks like this purple line. And if we put that into 100 grams of water, well, 100 grams of water is pretty standard for any kind of solubility chart. So that's information that, at least for this example, is not important. Now, if it said maybe we put it into 50 grams of water, well, we might have to kind of do a little bit of math here as a proportion and double things, but in this case, we can leave it the same. So if we have 60 grams of our NH4Cl. I'm just going to circle that. And then at 10 degrees Celsius, what would it look like? What would we actually see? And so if I look at this point, if I look at this graph right here, it looks like about where that purple line intersects at 10 degrees Celsius. It looks like, I don't know, and maybe we got to take a little bit of a guess. We say maybe 35 grams of it will, and remember what that line tells us, maximum solubility tells us that 35 grams will dissolve, all right? So what is it going to end up looking like? Well, if only 35 of it dissolves, how much is just sitting there on the bottom? Well, we added 60, right? So all this above that line, remember everything up here, right? It's saturated. It's just sitting there. So 60 minus the 35 that actually dissolved, that gives us 25 grams of that NH4Cl just kind of sitting there on the bottom. And the next part of the problem says, okay, well, what temperature do we have to heat it in order to get all that NH4Cl, ammonium chloride, to actually dissolve? Well, and in that case, I've got to look at what point on this graph for NH4Cl can I absorb all 60? Well, it looks like it intersects right about there. If I kind of travel along the 60 gram line, it looks like at about 70 degrees Celsius, all of that 60 grams of ammonium chloride would in fact dissolve. So here's an example of a problem where, just like I kind of talked about on the last slide, maybe we don't have 100 grams of water. What if it says in this one, how many grams, how would 170 grams of NaNO3 in 200 grams of water appear? Well, let's find the NaNO3. It looks like it's this blue line we'll focus on. But again, this table is based off of 100 grams. So how might I set that up to figure, and we could set up a proportion. So for every 170 grams, I've got 200 grams of water, of my NaNO3, and we'd set that up and set that equal to, okay, how many grams would that be over 100? And what we would find is that instead of 170 grams, to use this table, we would just say 85 grams of our solute, of our NaNO3, is going to dissolve. So if we look at our table here, at about 85 grams, and again, we're looking at this blue line, it looks like, at around, say, maybe 15 degrees Celsius or lower, the solution would be saturated. However, anything greater than 15 degrees Celsius, we're going to have an unsaturated solution. So what that means, again, is that we can add more of that NaNO3. So there's a lot more space for us to basically add more of that solute.